Welcome to the first unit in this class called Chemistry and Measurement. So once again, the unit is Chemistry and Measurement. Okay, at the top of your notes, you'll see a section where you can write the unit and the topic. So your topic is Chemistry and the Nature of Science. All right. So this is our first day of notes out of 4. The objectives are as follows. You will learn the importance of chemistry and the problem-solving nature of science. You will understand the scientific method and the steps involved. You'll be able to distinguish between a scientific hypothesis, theory, and law. You'll become familiar with some basic terms and principles of lab investigation, such as dependent, independent, and control variables. You don't need to write the objectives down, okay? But you should be writing the unit and topic down for every lesson, okay? So, in your notes, you will see a section for your quick write here. The quick write is designed just to get you thinking about today's topic or lesson. All right, so in 1 to 2 sentences, answer only one of the questions below. You don't need to write the question. All right, so what sort of things come to mind when you think of chemistry? How do you think chemistry has improved our lives? Once again, there's really no wrong answer. Just write what comes to mind. Okay? Go ahead and pause this if you need more time while you write. I'm going to move on. Okay, so don't write anything right now. Just listen and learn. I will tell you what to write on your notes. So right now, just listen and learn. So the importance of chemistry. Everything around us is chemistry. The air we breathe, the coins in our pockets, the material that makes up our electronic devices, the medicine in our medicine cabinets. Look around, it's all chemistry or matter. Studying chemistry is important. It allows us to solve many of the world's problems, everything from environmental issues to new medicines that treat cancer and other ailments. So chemistry, if we define it, it's the science that deals with the materials of our universe, matter, and the changes that these materials or matter undergo. So for your notes, there's 2 columns. On the left-hand column, or in the left-hand section, write the question. What is chemistry? Everything below the question here will go in the other column. Okay? In this case, the answer. So, question is written on the left-hand side. The answer here goes on the right-hand side. Okay? Go ahead and pause this while you write this down. I'm going to move on. Chemistry and the scientific method. Science and chemistry is about solving problems. Okay? To solve problems, scientists use something called the scientific method. The scientific method is a systematic, orderly process that utilizes a series of inquiry-based steps and observations about our natural world. So, once again, question here will go on your notes on the left-hand side. The answer here will go next to it on the right-hand side. Okay? Go ahead and pause this while you write. I'm going to move on. All right, so steps in the scientific method. Step 1, state the problem and make qualitative or quantitative observations. Well, what's that? A qualitative observation involves a physical description. The hair was blonde, or in this case, the quarter here is shiny or lustrous. So that is a qualitative observation, a physical description. Well, a quantitative observation involves a quantity or measurement. So if we take that same quarter and we put it on a scale here and we mass it, okay, it'll weigh 15.5 grams. That is a quantitative observation. It involves a measurement, or a number, if you will. Okay, step 2, formulate a hypothesis. A hypothesis is an idea or explanation based on observations. 3, perform experiments. An experiment is something we do to test the hypothesis. So it tells us whether our guess was essentially correct or wrong. Okay? And the data or information that we gather during the experiment allows us to validate or accept or reject our hypothesis. Okay? And finally, we do what's called iterate, or that just means to repeat experiments to confirm the results here. So, what steps make up the scientific method? Question on the left-hand side. The 4 steps here, in this case, the answer goes on the right-hand side of your notes. Okay, be sure to write small so you have room here. Go ahead and pause this while you write. I'm going to move on. All right, so hypotheses, theory, and law. Recall that a hypothesis is just an idea, okay, based on observations that has yet to be proven. Once a hypothesis has been confirmed through repeated experiments that consistently arrive at the same conclusion, we can begin to develop a scientific theory. So a scientific theory is an idea or explanation for some phenomenon that is based on and supported by evidence through observation, experimentation, and reasoning. Okay? It is different from a hypothesis in that it is supported with experimental evidence. So a theory is supported by evidence. Theories attempt to explain our natural world and can be further refined through additional experiments. A scientific law, on the other hand, is a descriptive generalization about how some aspect of the natural world behaves under stated circumstances. It is a readily observable fact about something and is often confirmed by by a mathematical expression such as Einstein's famous expression here, E equals mc squared. Both laws and theories are supported by experiments and empirical data. However, a law seeks to describe a natural action under a given set of conditions, and a theory is more of an explanation. It explains how and why something happens. Okay? So for example, consider the ideal gas law, which you'll learn about later in this class. PV, pressure volume, equals nRT. Okay? This mathematical expression describes and makes generalizations about the behavior of gas molecules in our natural world under a given set of conditions. Okay? On the other hand, consider the Big Bang Theory. There's no equation, there's no mathematical equation to really describe the Big Bang Theory. It simply seeks to explain the origin of our universe through ideas that have been supported through scientific research studies and evidence. Okay? Both a scientific theory and law are accepted to be true by the scientific community. Okay? So, for your notes, in science, what is the difference between a hypothesis, theory, and law? Once again, question here goes on the left-hand side. Answers go on the right-hand side. Okay, go ahead and pause this while you write. I'm going to move on. All right, so experimental design. We're almost done here. In every experiment, we have what are called variables. Variables may change or not change at all. So if we define it, a variable is any factor or condition, such as temperature, volume, or mass, that can change or remain constant in an experiment. An experiment has three kinds of variables: independent, dependent, and control or controlled variable. So what is a variable? For your notes here, question on the left-hand side, the answer on the right-hand side. Make sure you write down the three types here, the three examples. Go ahead and pause this while you write. I'm going to move on. Okay, so the last thing we're going to talk about today are these three different variables: independent, dependent, and control variables. So in an experiment, we have what are called variables. The independent variable is the variable that you, the person doing the experiment, change or manipulate in the experiment for a desired outcome or effect. It may be temperature. You may change the temperature of something, the pressure, or the amount of chemical available or being used. The dependent variable is the variable that changes. It is dependent, okay, upon the independent variable and is the variable being tested in the experiment. Okay? Control variables are variables that are kept constant to improve the accuracy of your experiment. Let's have our own little mini experiment here to give you an example of these variables. Let's say you want to compare the cleaning effectiveness of chemical brands X and Y on their ability to remove grass stains on clothing. In this experiment, there are many variables that could affect the outcome of your experiment. the amount of cleaning chemical, the size of the stain, the type of clothing or material. The independent variable in this case, the variable you manipulated in this case, would be the type of cleaning chemical. Did you use cleaning chemical X or did you use cleaning chemical Y? So you're manipulating these things, you're changing them. The dependent variable would be how well each stain was removed and eliminated from the clothing. It is dependent upon the independent variable. Okay? Control variables consisted of equal amounts of cleaner. So you use the same amount of cleaner, the same type of clothing, and the same stain size. Okay? So these control variables were used for accuracy. Okay? In other words, these control variables remained constant throughout the experiment, okay, to improve the accuracy of your experiment. All right? So, last one for this set of notes is, what is the difference between an independent, dependent, and control variable? Okay? Question on the left-hand side, answer here on the right-hand side. Go ahead and pause this. While you write, I'm going to move on. All right, so summarize. At the bottom of your notes, you'll see a summary section. You can always write your own, or you can do mine, okay? Explain the science of chemistry in your own words. Condense the scientific method, if you can, into one sentence. Make a Venn diagram that relates scientific law and scientific theory. How are they different? And in the middle, explain how they're the same. Design your own simple experiment and identify any independent variables, dependent variables, and control variables. Okay, go ahead and pause this while you finish your summary. Okay, and we'll see you next time for day 2.